All right, so let's go ahead and fit a model. Here we're going to go ahead, we're going to load our Tidyverse and Tidy Models packages, and we're going to use this Ames Iowa data that we've been using quite a bit lately. So let's go ahead, we're going to start by fitting a basic model, right? So to fit a model, a Mars model, we use the Mars function. And we need to set the mode. We need to tell it, is this a regression problem or classification? So the Mars function is not going to automatically detect, are you doing a regression modeling or are you doing classification? So we need to tell it. So we're going to go ahead. Now, the first time you run this, you may actually get an error that basically says that the engine requires a package called Earth. Okay? So if you do that, then what you'll need to do is to go ahead and do install packages, Earth, and that will install the required package. I've already got this installed on my end, but just realize that you may get that error the first time you run this. All right, so let's go ahead. We're going to run this Mars model, and we're just going to use sale price as a function of ground living area plus year built. So let's go ahead. Now, when we run this and we just print out Mars fit, we get this output here. Now, we see a few things. We see selected 9 of 10 terms and 2 of 2 predictors. We'll come back to this here in a second. We also see that we have these different metrics down here. We have RSS, so this is the residual sum of squares. We learned about this during the linear regression module. We also have this GCV, GR squared, and so on. I don't want you to be too worried about these values. These are just metrics that the model uses to try to figure out what is the right number of knots to use across our predictor variables. But we're not going to use this information for much of anything. All right, one thing to note here is I didn't do any kind of feature engineering. And that's because Mars has a unique attribute or characteristic that we don't actually need to normalize or standardize the numeric features. This is kind of built in within Mars, where it doesn't really care about the distribution of features nor the scale of the features. So that's kind of nice to know. So we didn't do any feature engineering because we don't need to. But if you do feature engineering, it's not going to hurt it by any means. All right, so we fit our model. Now, we can go ahead and look at the coefficients. So I'm going to pull out the coefficients using this right here. We're reaching in to get within the fit part of our object. And I'm going to pull out the coefficients. And we'll see that we get these values. So you can see we have this H. This means there's a hinge function, or this is actually where a knot is located. Right? We see we have several knots across the living area variable, and then several across the year built. All right, so what does this stuff mean? All right, well, let's kind of work through this. We're going to focus on the ground live area variable here. And we have a total of, 1, 2, 3, 4, 5 different knots for ground live area. We have one that's ground live area minus 1456. So that's right down here. We see that right here. And what this is saying is, for those homes that exceed 1,456 square feet, we see an increase in the sale price of $41.77. So for all those homes that exceed that 1,456 square feet, for every additional square feet, we see an increase of about $42 to the sale price. Now, that's the relationship up until ground living area gets to 2,169. So that's right here. So for a home that has greater than 2,169 square feet, then for every additional square foot, what we see is an increase of $27.57 per sale price, or in the sale price. And so that relationship exists for homes that are greater than 2169, but up until homes are about 3,194 square feet, right? So that's now right here. So once we get to 3,194 square feet, once homes exceed that much square footage, then we start seeing an increase in the sale price of $516 per additional square footage. Now, that exists up until this H3395 minus GR live area. Okay, so that is going to be right here. So what this says is for homes that are greater than 3,194 square feet, but less than 3,395, we see a decrease in sale price of $61.66. Okay, and then once we get homes that exceed 3,395 square feet, we see a decrease in sale price of $772. Okay, so it can be kind of tough to piece this together in our minds, and that's okay. I don't expect you to look at all these different knots that you see in your model results and instantly interpret them, but realize that this is kind of the relationship. It's got a very similar relationship that we see with linear regression, but it's for within certain ranges of that predictor variable, right? So if we were to look at, I kind of organized this all here in this notebook. Basically what we see here is as homes increase in sale price, as homes increase in the square footage, we see this steady increase in the additional, how each additional square footage impacts the sale price. But that works up until we get to a little bit over 3,000 square feet. And then all of a sudden we start seeing a negative relationship with sale price in our square footage. All right, so another thing to note here is, recall up here we see the selected 9 of 10 terms and 2 of 2 predictors. So what this means is we supplied 2 predictors, ground live area and year built, and it says 2 of 2 predictors. That means our final model used both of the predictors. Now it says selected 9 of 10. What that means is our model actually fit 10 knots, and then it pruned 1 off, and it only kept 9. Okay, so now we have 9 total terms. If we look down here, we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8 coefficients with our features plus 1 additional term for the intercept. Okay, so that's where this phrase in our model output is coming from. We retained a total of 9 terms or coefficients, and we used both of our predictors. All right, so let's extend this. Let's scale this up, and we're going to now fit a Mars model where sale price is a function of all our features. Okay, let's go ahead, apply that. And we notice we didn't do any type of feature engineering, so it used the numeric features as they are, and it used the categorical features as they are. And what results is we used 29 of 308 predictors. Now we have 308 predictors because our model is one hot encoding our categorical features, and we only retained a total of 29 of all these 308 features. Okay, and then we retained a total of 41 coefficients of an initial total of 45. So we had 45 total terms or coefficients, and then we pruned away 4 of those to get our final model. All right, so let's go ahead and take a look at our coefficients. Now there's a whole bunch of these. We're not going to go through these, but you can see that we have all these different knots for different features. Ground live area, year built, total basement square footage. We have a knot when we have different quality ratings and so on. Okay, so we have a whole bunch of different knots here. In fact, we have 41 different knots, or 41 total terms or coefficients. One of those is the intercept, so that means we have 40 knots around our different features. Okay, so that's fitting a full model. now, one last thing here is we can fit a model with interactions. So Mars models allows us to assess potential interactions between the different hinge functions. So how we model this is here, we use the exact same code that we used above, where we're doing a model where sale price is a function of all predictors. But what we're going to do here is add this prod degree. So this means allow second degree interactions. Let's go ahead and fit this. It's going to take a little bit longer because our model is doing assessing a whole bunch of possible interactions between our features. Now, if I look at my coefficients, what we're going to see here is now we have all these different knots or hinge functions. But if we come down, now we see we have this interaction. We have an interaction between this knot where year built is greater than 2002 and this total square footage is greater than 2,398. Okay. So this just allows us to take a look at different interactions. So here's a bullet here I added. So one of those interactions was right here. I think this was the first one I called out, where there's an interaction between year built minus 2002 and ground live area minus 2398. What this means is there is an interaction effect for those houses built after 2002 and have more than 2,398 square feet of living space. So there is a unique relationship between the sale price of a home and when the home is built after 2002 and has more than this much square footage.